Hello. Yes. So, welcome all in the morning, the very early morning panel discussion. So, a recap on the previous days. On the first day, we had a look on the main outcomes and documents of StoRIES. Highlights are the roadmap, the strategic research innovation agenda, and of course, the white paper, the sustainability assessment, the fire data, and so on. And yesterday, we went through actually each of the many outcomes. So as a summary, as a takeaway, for sure, one of the takeaways would be our perception of hybrid energy storage systems to enable synergies, but also bring benefits to different sectors, not only electricity and power sector, but also in different sectors. So in this panel discussion, sorry, my microphone. Okay, in this panel discussion, we have invited some that we will discuss with speakers from different sectors, how they perceive these benefits in their domain. So I would like to invite to take a place of the panel. First, Mehdi Zadeh is a professor at NTNU, and he represents transport sector and maritime. Thank you. Paola Mazzucchelli, Brussels delegate at Thirthe. She represents industry. Then Gaurav Visvanathan just arrived, head of market applications at Siemens Energy. Thank you for coming. And he represents applications and actually what is actually on the implementation phase. And then Jorge Nájera, researcher at CMAT, will tell us a bit more about grids. So thank you very much for coming for this discussion today. We will try to keep it 45 minutes approximately. And I would like to go straight to the first question. You can introduce yourself and then give a response to the question. Maybe the way that we have been seated, maybe you can start. So how hybrid energy storage systems can enhance resilience, flexibility, and efficiency across key sectors such as electricity, grids, industry, transport, and buildings. I guess you will represent grid sector. And yeah, you can start with your input. Yeah.
Yes. So, well, good morning, everyone here and also at home. Thank you for inviting me. Yeah, well, from the grid perspective, hybrid energy storage system can, of course, contribute to the flexibility, resilience, and efficiency. But as we all know, not just from the way of adding different features into one hybrid system, but from the way that the grid operator can use that new asset. In terms of resilience, we can say that hybrid energy storage system can contribute to the controllability of the system, to a system that is continuously increasing its uncontrollability due to renewable, among other issues. But the thing is that it's not just adding controllability, but it's adding different layers of controllability, because we can use this asset in acting fast to different events. We can also sustain power over time, and we could also help in recovering some areas during a restoration or whatever we want to do with this new hybrid system, depending on the combination of technologies, of course. But yeah, the thing is that we have like different layers of technologies, so we make the grid more tolerant to uncertainties. In terms of flexibility, what we have is, we all know, the kind of systems or the flexible services that different energy storage systems can provide to the grid, and well, ranging from frequency and voltage regulation to reducing congestions and also fostering the energy storage system penetration into the grid. So the thing here is that we have different flexible service within one asset, and the good thing about hybrid systems, or the way that they can help, is that we have an asset that can change the role along the day and depending on the event. And that's the important thing. We can change the role within the same asset. And in terms of efficiency, what we can say is that, okay, per se, I have a hybrid energy storage system is not improving the round efficiency of an energy storage system per se, but the thing is that if we take a look at the wider system or a wider level, we could reduce curtailment, we could also reduce power redispatch, we could also potentially reduce grid also like improvements in case of that they were needed. We can solve it with hybrid energy storage systems, and we could also limit like the aging associated to specific unit storages within the hybrid system, lowering also the operational cost. So what we're making at the end in terms of efficiency, helping the grid to get the most out of this asset. So, well, and one thing that we can learn from the recent Iberian blackout that we had last April, well, as more reports are stating, it's more a controllability issue than a capacity issue. And this kind of assets like hybrid energy storage system can help in mitigating this kind of problems that we have on the grid with this combination of layered controllability and stacked flexibility.
Thank you very much. Thank you very much. I see also Gaurav agreed with, he noted positively with many of your sayings. But I would like to hear your opinion on the application side. And actually, this is where, yeah, the market perspective on this.
So at the end of the day, it all comes down to maybe an introduction just quickly. So I'm Gaurav Vishwanathan. I work as the head of market applications for battery storage within the EU for Siemens Energy. Prior to that, for the last 8 years, I was working as a senior business development manager for RWE, which is one of the largest developers for various different technologies. So given that experience, what we see in the market, both from a developer side and also the product side, is that the number one bottleneck for deployment of BESS or other types of hybrid energy storage is not necessarily that there is not enough, let's say, sites available. It's more like there's a grid bottleneck. There's a lack of flexibility on the grid. We want to deploy stuff to improve that, but there's obviously, both all companies need to work hand in hand to ensure that we can have that kind of build out. Coming to the market applications themselves, so different technologies of even battery storage, or whether that's compressed air storage, hydrogen, all of them need to work in conjunction. We know that. And they essentially, for different durations and different levels of renewable energy penetration, different technologies can supplement and benefit each other and be targeting different types of applications. So let's start with a very low renewable energy penetration, which is around 10 or 20%. The grid, as we know it today, can still pretty much function. There's not that much variability introduced, but as you increase that percentage of renewables on the system, the first types of issues that you'll start noticing is essentially, you'll have voltage as one of the issues. And at the same time, you will have, from a grid frequency regulation point of view, you will have frequency drops more noticeable on the grid. And to compensate for those, you need fast responses, which are delivered usually by battery energy technologies and inverters to provide that kind of regulation so that you can bring back that 50 hertz instead of, that constant drop and constant increase in frequency. You need to be able to inject power and absorb power in a matter of seconds so that you can bring that frequency back at the right levels. At the same time, if you increase now the renewable penetration even further, 30 to 40%, the very dynamics and the physics of the grid starts to change. And what you start noticing is more of inertia dropping. With this high levels of renewable energy penetration, there's less inertia on the system because there's less rotating masses that were earlier present due to thermal power plants. and were provided by thermal power plants, and now they need to be compensated by other technologies. And now there's other technologies that come into play, right? So for you can have synchronous condensers, for example, for that real inertia on the system, in conjunction with battery storage for the synthetic inertia, plus providing the other types of services that come on top. So there's obviously ancillary services, which provides the base. You have other longer duration services like capacity markets, which are more suited for long-term battery storage. Also, if you want to do hydrogen, this is going more towards the mobility sector, which I'm sure our experts will speak about. But hydrogen is again for long-haul mobility usage. Yeah,
It's a hard to abate sector. Yeah,
exactly.
So yeah, I will pass the floor then to industry and Paula to tell us what kind of applications are on hybrid energy storage, how you see it from industry perspective. It's the same question actually.
Yeah, well, thank you very much, Spiridon. Good morning to everybody. My name is Paola Mazzucchelli, and I work for StoRIES, which is a research center located in Saragossa, Spain, but I'm their Brussels delegate. So indeed, I am referring to energy intensive industries mainly, which are those as covered in the Process for Planet Partnership, which is a co-program partnership of Horizon Europe, and which covers 10 hard-to-abate sectors like chemicals, pulp and paper, alumina, steel, cement, and other ones. So, and hard-to-abate sectors, indeed, they need several decarbonization technologies to be developed in order to foster their decarbonization, and several technologies which also need to be integrated in the current industrial processes, which are currently highly dependent on fossil fuels. Something which is very important is the fact that the majority of these processes need to be to run 24 hours per day, 7 days per week. As such, since one of the priorities of the industry is to increase, for instance, and move towards processes which are based on electrification, energy storage system and hybrid energy storage system can play an important role in ensuring the flexibility as well as the resilience of the system. For instance, CRSA is currently coordinating a EU-funded project which is called ELITE, and which aims at supporting the decarbonization of the ceramic industry. With this respect, we are developing and testing several electrification technologies to electrify some of the industrial processes for the production of ceramics, and they are tested in 3 different demo sites in Europe. But what we are doing as well is that we are analyzing and characterizing several materials which are byproduct of the production of ceramics, in order to see which ones are better suited to be used in thermal energy storage applications, indeed, in order to increase the reliability, resilience, and flexibility of the system.
Thank you very much. And actually, we had one of the recommendations, maybe you had missed them. It was the first day. The SRIA recommendations was 2 of them were focusing on industry, and the way that we could that we're saying it is that that hybrid energy storage, but energy storage in general, would be an enabler for industry decarbonization and electrifying some of the processes that are very energy intensive. Then we pass to the transport sector, and especially maritime, which is a very peculiar one, right? It's not freight transport, it's not aviation, has its own characteristics. And there I would like to Mehdi, to hear a bit from your side Yeah, the same question: how can hybrid energy storage systems can enhance resilience and efficiency in maritime sector, both on board and shore-based?
Thank you for the invitation and coordination. It's redundant. Good morning, everybody. So I'm working at the Institute for Marine Technology at NTNU, and on marine sector probably will follow the same trend as the other sectors. So in terms of energy storage and hybridization. But I can tell you also a little bit of a story. So because I work also, I used to work for car industry. So before I switched to ships at 2017, and then I started, promoting the so-called marine electrification. So with the simple mindset of let's electrify everything. Yeah. But at the time, it was really hard to imagine like a whole, energy transition. So the sector was happy with some, little bit emission cut, but not like, a whole paradigm shift. Yeah. So the vision was there, but implementation was still out of reach. And yeah, on cars, I mean, of course, the electrochemical is the trend and probably will be, and I believe also, marine and ships will also follow. But on marine systems, we should take one step back. So even before batteries, so basic fundamental, definition of electrification, as I keep saying, electrification is not batterification. So we started first, I mean, with the very simple concept of if you imagine you have a village which is in need of water, right? And you have houses and gardens, and you don't probably connect every river to a house or a garden. That's not efficient. And we have known the solution for a long time, like establishing a water reservoir somewhere, collect the water there as a collective source, and then distribute to consumers, right? But that simple concept was still missing on the energy systems, and that was the first phase of electrification. So let's get rid of conventional transmission system and establish a pool of electric energy on board, of course, even without batteries. But then we had, the primitive batteries like capacitors, right? So every power system has a capacitor bank, to stabilize. And that was the first step to establish the pool of energy. And then only in the phase two, battery came into the picture. And then, just to simply expand the pool of the existing pool of energy. So let's make it bigger and a little bit higher, water level, because you should prepare for all different demand, different loads, consumers. So that was how actually battery came to the picture, yet not as a primary source of energy, but as a, energy buffer mainly.
You're referring, sorry for interrupting, you're referring now on the services on board or?
Yeah.
Okay.
Only on board, yeah, exactly. So, but if you want to also take into the picture, ports, so that's getting even more interesting, because then you have, not only consumer, but you can use port for generating energy, exchanging energy. So it's not just like, ship logistics anymore, but look at it as an energy hub. Yeah, so then it comes to the picture, moving from hybridization and hybrid energy systems to integrated, so to say, energy systems. So then again, you collect, of course, you benefit from hybridization, but then also more and more from, coordination, communication, the energy logistics, as other colleagues also mentioned. So pretty much the same challenge that you have on land, and that's the point of sector coupling.
Very insightful. So I would go for a next round of questions, and this time will be more specific and targeted question to each of you. And I will start with industry and Paula. So what are the main challenges of industry decarbonization? and how could hybrid energy storage play a role on that front?
Yes, well, let's say that energy-intensive industries, at least when the process for plan partnership was launched, and the reason why it was launched had three main challenges. The first one, of course, is decarbonization, ensuring that industrial processes respect more and more, let's say, the environment with as well less emission of greenhouse gases. The importance of as well ensuring let's say, a resilience of the processes, so improving material and process efficiency. And then the third one is ensuring that the industry stays competitive. Now, as you might have seen in the recent years, the, let's say, attention has moved more on ensuring, more and more on ensuring the competitiveness of the industry. And as such, in developing systems which can ensure that the industry decarbonization go hand in hand with its competitiveness. So with this respect, we, let's say, are more and more interested in systems that can support the competitiveness of the transformation of industrial processing towards more decarbonized processes. And for instance, we believe that the upcoming Clean Industrial Deal calls, I don't know whether you're familiar with those, but okay, normally they should be published in the upcoming work program of Horizon Europe for 26-27. There will be two calls per year, one dedicated to industry decarbonization and the other one dedicated to the development of clean tech technologies, where energy storage is more included in the clean tech part. We believe that indeed, in the context also of the development of energy storage system, indeed it's important to keep supporting both the development of systems to decarbonize the industrial processes as well as clean tech technologies. We believe it's an important first step, for instance, for the European Competitiveness Fund proposal, which was recently adopted. We believe that putting together as priority industrial decarbonization and clean tech as well is an important first step. And I think that in this context, storage, which is a bit, as you said before, an enabler for industry decarbonization, so it can really make the link between these two worlds, so energy decarbonization, industrial decarbonization, which need more and more to go hand in hand.
Thank you very much. I would like to go back to grids again, because I have several questions there. I guess everybody has, and what's the role? So how can hybrid storage architecture be optimally integrated and operated within existing infrastructure? Because we're speaking about systems, existing infrastructure, so we cannot replace everything and just so we add components, we add complexity, as was mentioned before. So these, and we have your view on this. And of course, if there's any comment from the other panelists, or you want to add something, you can always ask for the mic.
Yes, feel free to contribute. Well, my ideas here is that in integrating hybrid energy storage system is not just, of course, a technical issue, but it is more about fitting a multi-technological and multi-capacity asset into frameworks that really is not that easy to fit. For example, if we look at grid codes are typically designed and developed for assets that perform a single or are following a single or a single action within the system. Let's say we have procedures used for generation, for loads, for storage, but what they do is that they regulate the connection, the operation, and how they react to different events and faults. But taking into account that those assets are in some way, we can expect how are they're going to behave. And it's not that with hybrid, we don't know how they're going to behave, but the thing is that they can behave in so many different ways to solve so many issues within the grid. So the thing is that we do not need to reinvent grid codes, but we need to, in some way, try to fit that dynamic or like multi-capability behavior of the hybrid energy storage system within the existing grid codes. And also, some kind of a similar way happened with markets because, well, there are not many regions that have flexibility markets, but those that have, they try to value one service at a time. And in case of hybrid, we can perform so many different actions that could potentially be included in different markets. But at the same way, we can be penalized for not being able to be compliant what we offered in different markets. So that's something that we need to regulate, because if not, we are not taking the advantage, or we are not putting the value in the extra or in the coordinated flexibility that the hybrid energy storage system is providing. If not, I mean, if we're going to try it as like just the sum of different storage systems, we are not making use of the hybrid part of that hybrid system. So that's something that we have to take into account. And also, well, there's another issue, which is like some institutions uh, still think that hybrid means also complex. And well, what's really complex is the power system and the grid. And what we're doing with hybrid energy storage system is trying to manage that complexity to to make it controllable in some way. So so what in some way, if we try to change that perspective, it's easier maybe to go from demonstration to deployment, maybe. So that I would say that the integration is based on trying to find grid codes that uh, recognize the role that hybrid can play in the grid, to have markets that value what they're giving to the system, and institutions that trust those systems. And I would say that's the point here.
And you touched upon market aspects, also aspects of standardization are implied here, I guess, grid codes. So this raises several questions on whether it's not only a technical issue, but also whether there are incentives there for asset owners to invest, and how actually these what are the revenue streams that are actually associated with hybrid energy storage. So I would like to pass. I would like to make this question to someone who is closer to the implementation. So he speaks with people that actually have assets, and to tell us more on the revenue streams and how can be further utilized to support the deployment of hybrid systems.
So essentially, you can look at battery storage or other types of storage in two different ways. You can look at it as a revenue provider or a cost saver. Yeah. And it depends on the application which you're referring to in both of those scenarios. I'd like to summarize three different, let's say, industry types where we see heavy usage of these kind of applications. And within those industries, I can talk about the different, let's say, revenue streams that are applicable to those, or cost saving that are applicable to those. The first one, as I already referred to, was the renewable energy markets, right? Here you can have front of the meter energy storage, or you can have a hybrid energy storage, which is behind the meter, combined with other renewable energy technologies. In front of the meter, you have access to multiple revenue streams because you can support the grid with ancillary services, which is like 60 to 80% of any business case. They are, let's say, very quick services that are provided by various energy technologies. And you essentially help support the grid from an availability perspective to regulate the frequency. Other than that, you have the capacity market, which provides kind of a, again, in at least in Germany, everybody loves insurances. And I love this analogy. everybody loves insurances for
Not many
everything.
Germans in there.
I guess in Belgium too. The capacity market is kind of like an insurance. You don't really need it, but you pay for it anyhow. But when you do need it, you better hope that you have an insurance to cover the cost. So it's kind of like the insurance where you have a capacity market where you're paying a retainer fee for these assets, energy storage assets to be available, but hope that you don't need them. Yeah. Other than that, you have the balancing mechanism, which is not available in every single country, but it's very specific to certain countries where the grid operator, for last second balancing of the grid, in case your solar farm isn't producing how much you thought it would produce, or your wind farm is not producing how much you thought, there is a massive discrepancy in the power, which needs to be compensated. And you have bids and offers on the market. The bids are for power injection, the offers are for power absorption, depending on what the grid actually needs. And these are very lucrative services that are available in countries like the UK, for example, which can be a very good, let's say, a revenue stream for most energy storage devices. The second industry that I wanted to refer to was the data center and AI. AI is a huge buzzword now, which is true. It is. But at the same time, what we're looking at in various markets, not necessarily the EU, but the US market, is that the electricity demand is heavily, let's say, now dependent, and even dependent on data center build out. I just read a Harvard paper which said that the actual GDP growth in the US was, without data center growth and AI growth, is 0.1% for the US. So it's basically AI and data center hype that is driving growth in the US market. And that is also having a cascading effect on the grid. There is not enough grid capacity available to power all of those data centers and AI. So what are the different companies doing? They want to build their own microgrids. They are saying that the grid will come later. Okay, but we need the growth today. We need to build out that grid today. And the problem associated with having your own microgrid is that data center and AI don't function with a grid like this, but rather they have massive spikes that need to be kind of smoothened out. And energy storage, especially hybrids here, can play a significant role. You can have a gas turbine in conjunction with synchronous condensers and battery storage, and even potentially hydrogen for the longer durations, to ensure that you have this microgrid secure. If you don't have, you need to be able to respond to very fast responses, which can be handled by certain inverter types and capacitors potentially. And then you need to also have power generation at the same time. Yeah, so this is kind of the second application where you're being paid by the data centers to have this microgrid stabilized and ensure that the power is available 24/7, because they can't have even a blip in their frequency. And that's also a lucrative market. The last one that I wanted to summarize, the third one, is more, again, dedicated to industry. And here, maybe you can also supplement that and educate us on that, because we come from the product side, let's say. In the industry, you need to decarbonize, which is true. We need to have a various mix of different energy storage types, like hydrogen for green steel or refining. But at the same time, you have battery storage for also, again, as a buffer. You can have load smoothing, or basically, energy shifting capabilities with the battery for industries as well, because they don't want to pay the demand charges, which are at peak loads or at peak times. So there is a cost saving aspect here, where you can, for your industry, charge the energy storage device in times of low, let's say, prices, and then discharge during high prices when the demand is high, keeping a stable, let's say, electricity cost for your industry. But at the same time, this is a cost saving aspect rather than a revenue making aspect. And the CapEx injection that is required in the beginning sometimes is too high, which is why the industries might not want to decarbonize in that sense. So there need to be regulatory conditions or incentives from TSOs or from other governments to enable the decarbonization of also the industry. At the end of the day, we're all working towards the same goal. But if there is no incentive, then they will also choose to do it later or not at all. Yeah. But this is the cost saving aspect that we can do.
Is it related to demand response, so shifting the most energy intensive machinery and so on at times with lower prices?
So it's more about looking at the industry as the entire industry as a whole. So we are actually looking at it in our own facilities at Siemens Energy in Berlin, where I'm located. There is the manufacturing area for gas turbines, and we have solar plants also powering part of that. But there is a business case for shifting the high peak that is required in the evenings instead of paying that high electricity charge, charging during the day when the solar panels are at the brightest, right? So the sun is the brightest, to actually charge the battery, then to shift it in the higher paying kind of hours. There is a slight business case, but at the same time, you have to evaluate it based on the industry per industry. It's not one size fits all.
Yeah, but sometimes comes in contact with labor laws and so on.
Exactly.
And, because some people say, I mean, from industry, they say it makes sense to have industry running. I mean, I want the factory running 24/7.
Yeah.
And this is the only way it makes money. And, okay, thank you very much. I would like to go back to maritime and I would like to know more about sector coupling on maritime sector and how hybrid energy storage can enable sector coupling.
Yeah, so again, from the basic things, so infrastructure for marine has been charging stations, which is simply onshore power supply. So then connecting grid to the port and supply the onboard batteries. Of course, in addition to onboard batteries, so you can supply also onboard loads. But onboard battery is the one which has the most consumption, and then something that you have completely available and for cars and road vehicles, so has been a little bit more challenging for ships. And from business perspective, has been the famous story of chicken and egg.
Yeah.
So chicken and egg could also both could be enablers, so depending on which one comes first. And then it was, incentives and policies that broke the loop, and then the developments start. And so nowadays, charging stations are not really, a big barrier for marine electrification. But then in terms of technical perspective, so you have most of these charging stations, for example, on a land like Norway, like very remote areas. So then you have big grids. So that's where actually the grid, consideration comes to the picture. And then you need to establish like a good storage systems. So then again, to increase the pool of energy at port, so then the grid can, start charging the storage systems. So when the ship arrives, then it can simply empty and, charge the vessel. So that's one trick to, compensate the weak grid in remote areas. But beyond that, I mean, as I mentioned, so the energy hub concept and integrated energy system. So when the hydrogen wave came and investment in hydrogen production. So then why not looking at port as a, energy provider and energy exchanger? So in connection with the grid and other sectors. So that's also where, the sector coupling happens. But then, of course, you need to also establish like a good management so that to make it profitable.
Mm-hmm. And if I'm not mistaken, when a ship arrives on the port, it's like you have a small town that really is power hungry, energy hungry. So it's how many megawatts, out of curiosity, is let's say a big cruise ship?
So a big cruise ship. So we have multi-megawatt. Let's say, I mean, recently I saw like one prototype with 6 megawatt, for example. So that's the highest, prototype I have seen. But also few megawatt is quite common, like 1, 2, 3 megawatt. And yeah, but that's still too much for like a weak grid and at remote areas. So it's like passenger and car ferries that you have on coastal and so-called fjords. Yeah, so you have all over the fjords like this.
If I'm not mistaken, in Norway, there are some cases, I guess here as well in Netherlands, with electrified some passenger vessels, right?
Yeah.
Or
Yeah.
partially.
Yeah, exactly.
electrified.
Exactly.
So
So now they are exponentially increasing, and then you should think about
I
it.
guess we're not going to see this in the big bulk carriers and containers, but some kind of, some smaller systems or some hybrid storage and power.
Yeah, I mean that's the point. So ships are very different. So from small ones and megawatt to 100 megawatt and even beyond. So you have like a moving city, and the case for large cruises, and that's so yeah. For today, I mean, probably batteries are not suited for that, but who knows the future? So that's what I should probably hear from electrochemists and technology people. Yeah.
Very interesting insights to see from grids, industry, application, and maritime. I would like to open the floor for any questions that you have to the panelists. I guess you have heard so many different topics, ideas all over the place, but this was the main idea of this panel discussion, to have different perspectives in a short time. Is there any question from the audience that you would like to ask? I don't see any hand. Maybe we can go on the second round of questions, because from my side, and we can maybe get back to the audience a bit later. So going back to industry and Paula, I would like to ask you what's here's the mic. So what hybrid energy storage system innovation could be interesting for the industry sector? So is there a specific technology that you're looking at, or a specific process that you're seeing more easier to electrify? Or?
Yeah. So maybe before I just wanted to mention something that has been discussed by Jorge and raised by Jorge and Laura, which is that indeed, well, we are evaluating how how industry can provide flexibility services as well to the grid. And actually, the project that I mentioned at the beginning, ELITE, is also analyzing how industry can provide this type of flexibility to the grid. The problem, let's say, is that somehow it's a new kind of professional figure for the industry, because this is not the job, let's say, the classical job of the industry. So this somehow also adds complexity to the whole transition. But okay, it's indeed an important one. And then I also wanted to mention that I was on an electric boat in Gothenburg. It was a very small boat, well, relatively small boat, I suppose, that were relying Gothenburg to one of the islands. Yeah, indeed. So it exists. It's possible, but indeed it's a small one for a small trip. And well, on the innovation, indeed, as I mentioned before, one of the priorities is electrification, and therefore different types of energy storage to support the electrification of the industry. But then, well, also, of course, industry is investing, especially the hard-to-abate ones like steel is investing a lot on the development of green hydrogen, well, on hydrogen, the use of hydrogen, and especially of green hydrogen, but also alternate carriers like ammonia. So we are also focusing on, let's say, on the development of different types of vectors and how they can be integrated in order to make the industrial processes more reliable and flexible, and at the same time.
Thanks a lot. I would like to get back to Guru to tell us a bit more about what kind of applications of hybrid energy storage potentially could add these, enable these flexible grids also mentioned a bit from Jorge before, but do you have some specific applications, or do you have um, are you oriented towards specific type of combination of energy storage technologies, or it's you just want some characteristics that would work at the current grid and based how market is shaped?
So I think now putting my developer hat on from my previous roles and not necessarily only on the product side, because from a product side, all I can say is, yeah, we're all in on batteries, right? But if I look at the full grid and taking a developer hat on, looking at it from a bird's eye view, what I can say is at the end of the day, it comes down all on incentives. If the TSO and the various schemes that are available in order to participate on the market, on the grid, to earn certain types of revenue are unavailable, nobody's going to build anything. At the end of the day, it all comes down to the various revenue streams that have been set up. And those revenue streams today target fast responses, capacity markets, balancing, and also energy arbitrage for various energy storage technologies. If in the future there are other types of applications, for example, black start, for example, inertia services, then there can be further deployments of other technologies and other market applications where hybrid energy storage together can work in conjunction. So let me give you a very concrete example. In Ireland, there was the DS3 services, which are ancillary services, very fast. It's the fastest frequency response requirement set by any TSO. It's the DS3 service, 150 milliseconds. This has existed for, I would say, since the start of the battery energy revolution, which is like about 5-6 years ago in Ireland, where we also constructed a number of batteries, about 80 megawatts back in the day. But now that service is essentially evolving. Why is that? Because Ireland is, if you think about it, it's an island. Yeah, and islands require microgrids. Microgrids means that you have a lack of inertia on the system to maintain that stability if you don't have certain types of technologies. And now, because Ireland has such significant renewable energy penetration, that inertia severely lacks. So recently, for a customer that I will not name, but for a customer, we deployed a hybrid energy storage device of a synchronous condenser, which provides 4,000 megawatts per second in conjunction with 160 megawatt hours of batteries. And those two need to talk to each other through a central brain to make sure that you can apply both those technologies at different points of time within the grid when that need occurs. So this is one of the examples where such technologies, such hybrid technologies are flourishing. But at the end of the day, hybrid deployments will come down to what revenues are you able to target? Are you incentivizing developers to build those technologies? I'll give you another example. Recently, and you can maybe help and supplement that for the Spanish market, actually. Recently, the TSO, after the Iberian blackout, the TSO is for grid applications for battery storage, implementing a rule for applying a synchronous condenser to every grid application. Why is that? Because the TSO says, you created the problem as the developer, now you solve it. Yeah? Which means that now all developers will be forced to do one of two things. One, you investigate what will it cost you to put the synchronous condenser with the battery storage, and you think that there is enough of a business case that you can essentially make a decent profit that you need in order to hit your own hurdle rates, right? Your own returns, because you also answer to the shareholders, right? That's kind of the thinking of a developer. The second thing that they will do is, okay, if the TSO has not incentivized me to put the synchronous condenser, but it is still a requirement, I will just not build out in Spain anymore. I will just go to some other country.
Yeah, exactly.
So it comes down to, can you have regulations in place that actually provide some form of incentives for developers, for IPPs, for different utilities to actually implement that technology? And it comes down to security of those revenues. Capacity markets provide as I said, it's a type of insurance, right? but it's also an insurance for the company themselves. So most projects, at least for the smaller IPPs, are debt financed. For debt finance projects, what do you need? You need security of revenue. Where is that security of revenue if your entire business case is based on merchant revenue, where you're applying for trading, energy arbitrage, or you have ancillary services, which you have not yet won? So basically, capacity markets provide this kind of security of revenue, which the banks can see as a contract, like a PPA. It's almost like a PPA for energy storage that can help finance your project. But if you don't get that finance, if you don't have that kind of contract, that kind of security, there are very few companies who would be willing to take the risk of building out anything. Yeah. So it's kind of about incentivizing the right applications, and the technology will follow. Yeah, that's kind of.
And this means that also that across Europe, there we have so many different energy markets. Some of them are not interconnected. They're using different schemes as well. I guess capacity markets not widespread.
Yeah.
And there are barriers and
Yeah, well, just one. I mean, I agree with everything you've said. I don't know what's your opinion, guys, but in this sense, you've just mentioned that about the inertia markers or primary frequency regulation markers that are something that it's more little bit beginning to be a thing now. But okay, that for me or from my understanding, that's for us.
I don't know.
That's-
You can continue until we receive some.
Do you want me to?
Yeah, I would go for a final statement from each of you, but since we caught fire, I don't know. Yeah.
Okay.
It's a fire alarm. Give them a hand, please. We'll go straight for coffee break. Thank you very much. Thank you.
Yeah.
Hello, hello. Yep. Oh, good. Yeah. To be honest. Hello. Great. All right. I think we'll get started. Yes. Good morning. Good morning, everyone. Yes, still morning. It's good to have you here for the final panel of the StoRIES conference. I hope you've all had a good and interesting time. A little introduction on myself. My name is Killian Totterdell. I work with Form Energy. We're a US-based manufacturer of iron-air batteries. So these are 100-hour long-duration storage assets for energy resilience, grid boosting, and renewable integration are the sort of the big things we focus on. And so I'm really pleased to be joined by three panelists here. So we'll have two in person, and then Francesco will join online. But firstly, I'd like to introduce Linda Borelli, who is a associate professor at the University of Perugia working on energy storage and hybrid systems. So Linda, if you'd like to join me on stage, well, stage as it exists. And also Ignacio Esenio, who's a team leader in the European Commission working on energy system integration in DG Ener. Yes, please take a seat. And then I believe joining online, hopefully all here, we have Francesco Apicci, who's a co-founder and chief product officer, I believe, in Energy Dome. Francesco, are you with us? Not quite. Oh. Okay, so he's going to log out and back in, but that's fine. I think what we'll do is we'll kick off with a few opening remarks from our panelists to give a little bit of perspective on the topic that we have today on hybrid systems and how we can make sure they become a reality within the energy system. So perhaps first I'll hand over to Linda to give some thoughts. The microphone should be on.
And okay, I am from a university. I think that my role in this panel is to maybe to suggest some points to provide a long-term vision, because in the lacking, in my opinion, global strategies and implementation strategies at the European level. I think that industries, industrial players self-organize according to the current demands of the market. And so there are some points, in my opinion, to be highlighted. The first point relates to the title of this panel. Okay, it mentions short time and long duration energy storage. I am my research is focused also on long-term energy storage. So long duration, long term, you all are experts, but in my opinion, we need to spend some minutes to highlight this difference. Long term is the seasonal energy storage, seasonal, annual, and so on. So I understand that it is not the urgency of now, of today. Okay, but I would like to highlight that in the energy world, there is a very big differences between when we speak about short and mid-term and we speak about long-term energy storage. Differences that are also in the technologies. So which are the strategies in the technology deployment to address these aspects? So we know how to address short-term and mid-term energy storage at least at the technological point of view, but it is not clear how to address the long-term energy storage aspect. And it is not clear which will be the demand of a long-term energy storage. Okay, it is a point that nowadays is not, there is no feeling of this, but we have to address with the seasonal fluctuation of renewables. Okay, so how to pass the winter in the south of Europe, if we refer to the Europe, or how to pass the summer in the north. And in the recent years, my feeling is that the European Commission trusts hydrogen for this issue, but there are some issues to be solved in the technology scalability. But I don't want to enter in the technology discussion in the volume that is needed for the storage of this bulk capacity that will be needed. With Stefano, we provide some studies in the assessment of the long-term energy storage demand at European level, and it is in the order of thousands of terawatt hour. Okay, this is an enormous capacity, and it can't be addressed only through hydrogen, because the hydrogen has a very, very low volumetric energy density. And nowadays, hydrogen, the storage viable solution is the underground storage. Underground storage has a medium pressure of 130 bar. At this pressure, the volumetric energy density of hydrogen is 0.3, almost 0.3 kilowatt hour per liter. Consider that gasoline, similar fossil liquid fuel, has a volumetric energy density of almost 10 kilowatt hour per liter. Okay, so we have not the space, the volume, available volumes at the systemic level, the European scale, to store all this amount of the hydrogen vessels. And okay, this is so we need complementary paths, complementary solutions to address this point. But the problem is that nowadays it is not clear. Okay, so when we speak about the long-term energy storage, we need also to also from a commission for investment in research, we need also to invest on development of technologies to address the long-term energy storage, not only the implementation, but for the short-term, mid-term. Obviously, research improvements in all technology is always needed and welcome, but there is a very different situation. So this is the first point that I would like you to point to you for a discussion. And the second point is an aspect that relates to also to the panel before. Since we can highlight that nowadays energy storage is only marginally integrated in the electric system at the European level. So with respect to the capacity, the generation capacity at the European level. This is due because there is not a business model, and a business model is missing, because in my opinion, at now, I hope that some news, at now there is not a new tariff scheme that remunerates the services provided by energy storage. So the flexibility in power and also in energy, it depends on the time frame, the storage time frame we refer, that we mentioned also before when we speak about it with frequency regulation, voltage regulation, but then frequency regulation. And this time we are at the short and mid term. And okay, this is another point because if there is a business model, energy storage can be profitable. And otherwise, the industrial players, as I said before, self-arrange, self-found different solutions. For example, in the recent period, some owners of renewable plants contacted me for analysis for energy storage integration, but for a different aspect, is an indirect need of energy storage from an economic point of view, because as you know, during the day where photovoltaic solar energy is exploited, we have an excess of production, and the price for electricity delivery to the grid already went to zero sometimes during the summer. Okay, so the owners of energy storage, renewable PV plants asked me, okay, is it possible, can you assess if it is profitable for us to integrate energy storage to shift the delivery in the grid of energy produced during the day when the prices will be higher? Okay, but so at least Italy, yeah. So at least the energy will be anyway needed, also from economic point of view. But I think that provision of the electric tariff scheme would support it, would have supported this transition and this transformative impact of energy storage towards the electric system. Okay.
Great. So just quick follow-up question. I think, you touched on something really important there about the sort of leading role that research plays and then goes into, turning things into actual technologies and companies. I mean, with Form Energy, so we do iron air batteries. The initial research on that was done in the 70s by NASA. It was done by the Swedish National Lab, and they explored them for cars, useless for cars. But that initial research and then gave the foundation and the proof point, which allowed us to go to company. You mentioned that, first thing is to quantify what is the actual problem you're trying to solve and identify. How do you approach that, and how important is the way you quantify the problem to then steering the technological research that you go about?
Olga will be happy on my question, also my hand. For example, is a field of my research together with Stefano, the exploitation of other dense energy storage carrier. Specifically, we propose the use of reactive metals, in particular of aluminum, as a dense and solid state or liquid state, it depends, energy storage carrier. And to give you a number, aluminum has an energy density of 23, about 23 kilowatt hour per liter. So it is 23 versus 0.3 or 2.3 kilowatt hours per liter if hydrogen is liquefied, but considering only the active species, not the tanks, and not the system, and so on. And aluminum is the most exploited raw metals in the industry.
There's a few more, but
it's one of the most and there is no problem for safety, for environmental aspects. So you can leave a storage in open air of aluminum for years, and okay, it will be there without problem. And aluminum can be, so in a storage system you have the charge and the discharge. Okay, for the charge, if we refer to aluminum, it is the power to metal process. Okay, and we have not to worry about this because we already have a smelting aluminum industry, and the smelting aluminum industry is already decarbonizing itself because it is required. It's a process that you know very well. And this process, okay, already developed some technology as an inner electrodes for the smelting. Okay, we have to focus our attention only on the discharge process, the metal to X, to power, to hydrogen, to heat. And it is easy to done because aluminum, as all the reactive metals, reacts with water, in our case with steam, and it produces a lot of hydrogen and a lot of heat. So it can be converted back to power using fuel cells and other conventional gas turbine, steam turbine technologies. And it is also coming back to the topic of the first panel. It is a path suitable for the cross-sectorial applications because it's a globally a power to X process. And the process is inherently recyclable since the oxidation of aluminum produces hydrogen, it as I already said, but also alumina. And alumina can be recycled back to the smelting to produce again aluminum using this case renewable energy. And the process that we propose is the use of the oxidation aluminum with steam at about 900 Celsius degrees. And this is the temperature at which alumina is produced as a gamma alumina, which is the best type alumina to be recycled back in the smelting industry. So this is the idea.
Yeah.
So we propose not only problems, but some answers or proposal to be further investigated. But this is what I said before. For a long time energy storage, we need still a support for the development of technologies, not only for the implementation.
That's
Thank you
super
for
interesting.
your question.
I mean, aluminum is a very interesting technology pathway, to say the least. So it's also a really interesting sector because in Europe today, I mean, one of the core messages from the aluminum sector is we need firm power. We can maybe flex a little bit, an hour, but it's very hard for us to do more than that. And I guess when you're looking at energy system integration and how do we think about the integration of industrial demand, flexibility, storage, it's one of those sort of nexus questions of trying to bring together the right technologies and market incentives to manage a much more challenging system. So I guess this is your work, Ignacio, and it'd be very interesting to hear how you're approaching those kind of questions.
Well, thanks a lot for the invitation, and to interact with the research world and with the research projects that we are funding for regulation. Indeed, so I'm defining the system integration. That's a big umbrella. It means a lot of different things. And storage is certainly a very important part of that storage, and more generally, flexibility. I would say, and we are working, so you just mentioned the electrification of industries. We are currently working on a electrification action plan that will be adopted at the end of the first quarter of next year, 2026. And we will, of course, touch on the issue of electrification of industry. What I'd like to say is that, I mean, for storage, first of all, so let's first consider the market drivers and whether we do have strong price signals for development of storage demand. The impression right now, because of the situation that you mentioned, being that we call cannibalization of the solar industry in particular, but the wind industry as well. Last weekend we had very strong winds across Europe. In Belgium, there were zero or negative prices for many hours. The same in Denmark, Netherlands, etc. So this is a cannibalization. So this, of course, is a bad signal for renewables investment, something we need to fix. But it's also a very strong price signal for flexibility. This we see from the market that clearly this is really unleashing a wave of investments in batteries, specifically to mention the technology, but a wave of investments in flexibility for the purposes mostly daily and weekly flexibility. Daily flexibility mostly for solar, where it is so predictable that you will have this situation, you know, you will have negative prices, you can know that months in advance in a way. At that hour, you're going to have negative prices. and weekly, mostly for wind, which have different needs. Um, so we see a market driver emerging there. So far, flexibility was remunerated mostly through grid services, balancing markets, ancillary services, frequency restoration, etc. Now we start to see a truly market-based development. As I say, technologically, mostly a practice for the moment. But that's mostly short-term flexibility. And this is kind of the easy fix in a way. But clearly, I mean, what I see often is that things are happening in the engineering system faster than people had anticipated. People who were signing for PPAs for the new solar installation in Spain 3 years ago have not anticipated this level of negative prices today. They thought it would come later. So clearly something is not working in the models. And then we see, because in a way it was absolutely predictable, but okay. And of course, I was asking you the country because in Italy this is much less the case, much less than in the Netherlands, than in Germany, etc. Because you still rely a lot on gas to fix the prices. So the countries that rely less on gas to fix the prices, the less we rely on gas, the more negative prices we are going to have. And the more difficult it's going to be to recover your investments. Okay. So things are moving on a market basis on the daily flexibility. Now we are quite concerned about more long-term flexibility, as you were mentioning, and especially seasonal. I disagree, Linda, that the European Commission sees hydrogen as the solution. Hydrogen is a very specific. I mean, in our internal discussions about seasonal flexibility, which we have a lot, what often comes up is rather heat, so thermal storage rather than hydrogen. We need hydrogen. We have had to make a lot of regulations and initiatives to create this market ex nihilo because it didn't exist at all. That does not mean that we see hydrogen everywhere. We don't see hydrogen heating houses. We don't see hydrogen. So for long-term seasonal storage of electricity, hydrogen, I personally have my doubts, but I'm not here to decide on technologies. But in any case, I don't see that is a preference in the Commission for that. And I think we have no preference in terms of what should be the technological solution for seasonal flexibility of the electricity system. We certainly need the crisis quality mechanism. And so we need to create price signals. And I think there is a missing market for long-term flexibility, for seasonal flexibility. It's clear that, and we have said in exchange, I think, it's very difficult to make an investment based on using a storage cycle just once a year. This is very, very difficult to imagine today. With batteries, we have storage cycles that can go up once a day or twice a day. So it's very difficult to imagine that. But in a way, we have to create. So what we did in the revision of the electricity regulation last year was to create a whole process for flexibility needs. We took note of the fact that there was not enough flexibility in the system compared to what was needed already, especially when it comes to achieving the 2030 targets of renewable integration. And so we had a set of articles. And these articles created the flexibility needs assessment. We adopted with ACER and StoRIES adopted the methodology, how to measure this flexibility needs. I don't know how many of you have been working on that. I looked at that, but it's actually very complex to do. And what is important is to distinguish it from adequacy as a need. Having an adequacy need, so missing adequacy in the system is really whether you are able to cover your peak demand at any given moment, which is not exactly the same as having a need for flexibility. But some people in the system have difficulties to understand that. So it's true that the two are connected. In the end, I think we have a strong methodology that was adopted by ACER the summer, and now member states will start doing the flexibility needs assessment, and so putting figures of how much flexibility they need in the system. Hopefully, they will do it right, which means that they will look at daily, weekly, and seasonal. This is the wording we use. Daily, weekly, and seasonal flexibility. And so that there will be a figure also on seasonal flexibility. which will be related, of course, to modeling exercises that I might have been doing, that we do also internally in the commission, and we see this modeling needs also 2030. And and so there will be a trigger for that. And if the estimation is that the market will not be able to deliver, and I think we see that for seasonal, it's going to be difficult, then member states have the possibility to provide subsidies and state aid in the form of the support scheme specifically. And the idea is that that support scheme will be open even beyond storage, by the way. So it's open to flexibility. It's also open to demand response. We don't know at this point whether seasonal flexibility needs are to be covered by demand response or by storage, or probably a combination of the two. In my view, in these winter-related peak demand in countries with high heating needs, etc., some demand response will also be needed to cover those without using fossil resources. But in any case, the support scheme, so this state aid has to work in a way that and so that we don't determine what is the best technology. Of course, in parallel, we also have to continue investing in research and innovation, and demonstration, in first of a kind pilot schemes, etc., to try to see what technologies can provide solutions. But at this point, this state aid, it will start coming, I'm sure, in some member states sooner or later, especially in those with cold temperatures, and we will see where the solutions start to emerge. This is always a very important moment, like the MAX you have had in Italy. It's a very important moment for batteries. You have a price discovery mechanism thanks to an auction. You have an auction and you say, okay, what is the price of this? And it was lower than expected by the market, right? This happened with renewables 15 years ago. Now it's happening with batteries. Price discovery through auctions is very important. And I think, hopefully, specifically for long duration storage, long duration flexibility, seasonal flexibility, we will have also this price discovery mechanism. We'll start to see what are the best technologies. So this is the process that we have set out there for seasonal flexibility. There are, of course, many other elements. You mentioned big piece, network charges, or big piece. This is very important. So far, the European Union level, we have not regulated big piece. This remains national competence, has been respected as national competence. In the electricity market regulation, we have some high-level principles, including the TOPEX approach, for instance, is quite important in terms of flexibility and digitalization. But we have not regulated the details of that. But we did issue a guidance that I encourage you to look at, that was issued by the Commission very early in July, I think the 2nd or 3rd of July, a guidance on network charges. And of course, the main message of the guidance is we cannot, in the energy transition, we cannot continue to have rigid tariffs. Tariffs need to be flexible themselves and need to encourage flexibility. Essentially, cannot use tariffs. Of course, if you don't have smart meters, it's a bit difficult to implement that. So certain countries like Germany have a big penalty. But in principle, you can imagine solutions even without smart meters. And of course, there is a specific chapters also in the guidance referring to storage in particular. There are many problems for storage. One of the problems is that the tariffs are too rich to actually develop a business case in the basis of arbitrage and to play in the different electricity prices, because the grid tariff is too rigid. Another problem is that you often pay twice the tariff or certain taxes like VAT. And these are all elements that really we also think that in terms of accessing the grid, flexible connection agreements is going to be a very important solution in the future, because we will have grid constraints. I mean, the grid does not get up just like that. So we will continue to have grid constraints. So we need to make the best possible use of the grid. And we think flexible connection agreements is a very good solution, including in particular for storage, in the sense that you accept a contractual relationship with the system operator, where you accept that you are going to be curtailed at certain moments if needed, but that will depend on the system. So it's a different relationship with the system operator from normal access contract, and we think it has a lot of potential. But of course, we have to see implementation by member states because some member states are implementing these in a relatively weird way. Now the task we have, and that was also in the emergency regulation, is that national regulators have to create a framework for these flexible connection agreements, and we think that it's important to have fair terms and clear terms on how these flexible connection agreements are supposed to work. I can speak of many other topics listen and maybe to also give the floor to Francesco, and if you have any further questions, please come in.
Sure. No, it was really, really interesting remarks. I mean, you covered a lot of ground. I think there's points with yeah, the very real collapse of the PPA market right now. I think you touched on. You talked about the flexibility needs assessment. I mean, one part of the flexibility needs assessment that I think is very positive is that the methodology is explicit about the wide range of technologies and durations that must be assessed. So 100-hour storage should be assessed, which we're obviously delighted with. But you also mentioned price discovery and auctions. And I think one of the really interesting things about long duration storage is that it's very difficult to run an auction for it because you have a variety of round trip efficiencies, durations. You can have locational signals, where can you actually build this stuff? What's the system lifetime? And so one of the challenges is how do we create a sophisticated auction design? Because you can't just say, give us the cheapest megawatt, because it really can depend. Is that something the Commission is really thinking about in terms of the implementation of the outcomes of the flex needs assessment?
The state aid or support scheme has to be designed, but there are some high-level principles about what kind of payment that we have. It has to be the neutral, as I was saying before, etc. I think probably we do need to enter into this, and probably we need to run a study. Because I've heard a lot of discussions precisely about how to distinguish the different storage needs, the different hours that you are going to cover, etc. Also from a network perspective. And I'm not sure that we have the really made off-the-shelf replies to this question. And they are complex, and we need to address them finally. So I'll think about it for the next study.
It's a bit of a pet issue of mine, so I'm sorry for putting you on the spot with it. But why don't we let Francesco come in, and then we'll go. I mean, Francesco, as someone who's actually at building projects and trying to make the business case work, I don't know how you react to what's been said on the panel so far, and any points you'd like to make. I just note you're muted as well. Yeah.
Can you hear me?
Yes.
Okay. Yeah, hi everybody, and apologies for not being there in person. I'm struggling to hear part of the intervention before me, so apologies if I come in and saying things that have already been said. But yeah, I'm the co-founder and chief commercial officer of Energy Dome. We are 8 to 10 hour, let's say, long duration energy storage technology developer. We have our own technology. We are based in Milan. It's a European company. And currently we have deployed a 200 megawatt hour facility in Italy, which is now operational since this summer. And we have contracted already 1 gigawatt hour of projects that we are deploying in Europe and abroad. And the pipeline of, let's say, depending on how you qualify, but I think quite a solid pipeline to deploy around 10 gigawatt hour of this project. So we are, let's say, out of the scale-up phase of the technology and all into the commercial deployment. Can say many things, but probably one thing that we struggled, and I would like to pick on what was said before on the difficulties of running these auctions, and particularly we are very close to the Max auction that just happened, that was being presented as a success in terms of pricing, at least compared to the expectation for sure. But I think, I mean, two things there. The first of all, in my view, that's the way to go. Long-term auction and long-term pricing signals is what has driven down the cost of renewables before storage in solar and wind in the past, and is what in our view what the market needs, and I think Max is really a proof for that, because if the market is aligned to have a clear buying signal with clear long-term rules, the market reacts very, very well. The point is, and on the opposite, I don't think long duration energy storage could ever be built just leaving it to a merchant signal or waiting for developers to hope that there will be negative pricing in the future and betting on that. I don't think this is a market that can actually work without long-term revenues certainty, at least. Then coming to the auctions, I think as Europeans, we need to be a bit careful of how we structure this kind of auctions, right? Because we are, as Energy Dome, I think, a testament that the long duration energy storage industry could still be a European play, and it's not yet lost to Chinese lithium-ion suppliers. And I think we need, this is an important point, at least in our view, right? I mean, we are giving jobs to Europeans. We are opening factories in Europe. We just opened a factory in northern Italy to manufacture our own domes. We are giving jobs to 40 people there and growing. But the way Max was built was effectively to favor lithium-ion Chinese technology. I would be very happy to say we have a European lithium-ion supply chain, but it's not anymore true. I think that's a game we have lost, and I think we can be strategic somehow in these type of auctions in the longer run to probably be strategic and favor, let's say, also a European economic growth and independence from a technology standpoint, instead of having to rely on foreign supplies. And don't get me wrong, I'm not suggesting that these auctions are built to favor European supply chain versus competitiveness of these. So we don't want to be in a favored trackway, but we also don't want to be disfavored and having to bid into auctions that are clearly built for lithium-ion batteries with the regulations that put our pricing as of the start 20 to 30% less competitive compared to a lithium-ion supplier. So I'm just sorry, it's very close to us, but it is a reality. I think Europe has an opportunity in the long duration energy storage market to still play a leading role on a global basis, and I think we are seeing it at the moment. Our main market is not Europe. Our main market is the US. Out of that 10 gigawatt-hour of pipeline, more than half is currently in the United States, because in the United States there are all sorts of RFPs that certainly put us in competition with other types of technologies, but they consider 8+ hour duration as a critical component of the electrical load carrying capacity and of the stability of the grid, as well as capacity. So it's a mix of energy and capacity play. I still think that in Europe we can do a lot and be a bit more pragmatic and strategic about how we develop our own electricity market of the future, and at the same time think about European competitiveness.
I 100% agree, Francesco. I often say I look forward to the 2035 European strategy to reclaim the LDES industry from China, because we're so passive sometimes at being proactive about what's coming ahead, and we sometimes look a bit backwards. I'm curious. I mean, when it comes to the business model for you, Francesco, how are you looking at commercializing these plants today? What do you see as the big avenues for building commercial projects?
So at the moment, the projects we have in, let's say, in Europe are mainly used for providing our customers with carbon-free energy. So this is a way that our customers see for decarbonizing the grid and future-proof their supply of energy. Obviously, it comes with the green premium in Europe. So there is a big discussion we could open, for example, on let's say carbon-free energy accounting methods, right? And having time matching as a requirement and not just as an optionality. Obviously, that will be the El Dorado for long duration energy storage, right? Because if loads were to account for renewable energy only if that renewable energy was produced when they actually consume it, that would be certainly let's say a game changer in the space. So at the moment we are looking at mainly off-takers. We have signed a tolling agreement with Engie, which will use our facility in Italy for let's say providing carbon-free energy PPAs to their end customers. And we are working with hyperscalers to provide them with clean round-the-clock power.
Great. Yeah, you touched on a really big issue there. There's, for those not aware, the Greenhouse Gas Protocol, which is sort of the accounting methodology for corporate sustainability. They're currently under revision, and there is a brutal fight going on over whether corporates continue to use annual accounting of renewable energy and certificates, or whether they'll have to move to, as you say, Francesca, the granular reporting approach. And it's becoming quite brutal, actually, the fight over that. And well, we're all wishing for some good news out of the end of that process. About 5-10 minutes left. I know, Linda, you had a question for Ignacio, so if you want to fire ahead, and then I'll open it up if there's any questions from the floor as well.
Something similar introduced in Europe as an indication of the and with mitigation, because I think that we had in Europe, I know better the Italian situation, what was in the previous years, but it is the adoption of the European directive. So we pay incentives for renewables, very high incentives for renewables, and I think that it starts it was probably similar to this one, to the Chinese one, were adopted in the past. Nowadays, the situation will be completely different. But anyway, we are in Europe. I don't know which is the share of renewables with respect to the global generation in terms of between 40 to 50. segregata, depending on the year. But so the clean energy transition is almost at the midterm, and if to meet a supporting measures to go in with storage in parallel with the further penetration of renewables, if the one I mentioned before could be a strategy to be implemented. Sorry, it's a bit complex question, but what's the framework is
No worries. Let me perhaps first say hello to Francesco, because I realized we met already when we came to visit the director of Forensic, and I was in that meeting. And just to react to two elements.
Ignacio, I'm not hearing you very well. Sorry for
The
interrupting.
microphone isn't great, I'm afraid.
If
Just
you
make
can
sure you
just-
speak clearly into it.
Yeah, sorry.
Yeah, I don't know.
Okay. So in any case, I just wanted to react to two elements. So I tried to make clear in my intervention that we do see different flexibility needs, but these need to be distinguished because they have different, they respond to different necessities in the system. Of course, an option has to be net neutral, but there is always a cheapest option among technologies that can provide that service. But if you don't distinguish the services properly, then you are probably missing something in the other technology that was more expensive but gives you a different benefit. So the trick of this kind of options is, I think Maxe is a very early example. I think it was very focused on daily and short-term flexibility needs. And I was trying to explain about the process that will in principle lead to identification of needs for seasonal flexibility. That should lead to their own options for seasonal flexibility. This is my point. The second is discussion in the greenhouse gas protocol, discussions around PPAs and time matching. We used to say only matching, but now the market is 50 minutes, so it's time matching indeed. These are very important discussions. We are looking at that very carefully. Indeed, if the PPA buyer is asking for a better matching between the consumption and the demand, you have a very strong incentive for storage and flexibility. That is I just want to make clear that there's no intention to regulate this from the Commission. So we are not going to say PPAs have to be time matching, but certainly we think it's very important to have this.
Yeah, agreed.
So the guarantees of origin system needs to provide for them. And this is not the case very often. And probably from regulatory perspective, what we can do is to ensure that the framework of guarantees of origin provides for that. I just note that the new standard for guarantees of origin developed by Sensenelec with the AIB, so I'm not going to go into details, but there's a new standard on indeed time matching that includes a specific reference to storage and gives specific rules to integrate the guarantees of origin for storage as well in the calculation for the guarantees of origin. So this development, we think it's very important, and in the litigation action plan and a recommendation on PPAs that we are going to do to member states also in the first quarter of 2026, we will go into this topic, which we find very important. Hybrid installations, compulsory hybrid installations. First of all, this is something that is happening. Actually, so I think it's Hungary, the country where, as you know, it's one of the countries with the highest share of solar in the world. Hungary, surprisingly, but it is. They have grid constraints, and so I think around 2 years ago they decided the rule that you cannot connect without storage, installation without storage. I do not think this is a very good approach. I think we need to have the right market signals to ensure that first demand side flexibility can also compete, but also all forms of storage can compete. So hybrid is one possibility. I'm very much personally in favor of hybrid. I think it's a very good solution. in many cases, but we need standalone batteries as well. And in many cases, standalone, from a system perspective, is going to deliver a better service than a hybrid installation. Okay. And finally, you also need storage behind the meter, especially in industrial installations, commercial installations, etc. You will also need a lot of storage on the demand side to ensure flexibility on the demand side. So to have a system that only relies on hybrid installations to provide flexibility, yeah, but let's see. I think the market is pushing in that direction. So today, at least in the countries where there is high solar penetration, because of negative prices, I think it's becoming very difficult to sign a PPA without solar, without batteries. Sorry. Except that some buyers do not care about the time matching. Some buyers, they only buy the guarantees of origin. And those buyers, they may not care at all that the value of that generation is close to zero.
Yep.
So we come back to the real issue of the PPAs. So for me, it's not a matter of regulating this. You cannot force those buyers to install storage, but we need to come to a logical solution to this, because it doesn't make sense that they spend so much money into buying electricity that has no value. The only thing they are buying is the guarantee of origin. And this is not good for the system. So this we need this to evolve in the next year.
Indeed. Well, I mean, the challenge with the PPA market now is that there are no buyers anymore. So I think there was 2 PPAs signed in Germany in the first half of the year. That was it. I mean, it's a massive collapse of, excuse me, a huge collapse in the market of late. So I think hybrid is the future there, but it's as you say, how do we get the frameworks in place? We're running way over time, but I do appreciate having given anyone an opportunity. Super quickly, we can try. Do you mind just shouting out your question, and we'll get into it, and then I'll let the gentleman and just you and behind you. Sorry. Okay. I mean, sure. Yes. And I'll repeat it for your benefit, Francesco.
Oh, I'm sorry.
Great.
I was Denmark. So it's very interesting and very sedating discussion here. This is more maybe to the political perspective. You raised earlier the point that on the seasonal storage perspective, you're also interested in the heat sector. And like sector coupling is the area I'd like to raise the question. When it goes towards sector coupling, we have other barriers to take down. There's often taxation barriers that just make it hard to couple. There's also modeling barriers that maybe the targets, solution targets, and measures are not always informed by potential benefits of sector coupling. So what is the work in that direction? What are barriers that you're going to take down in that area?
Okay.
What's the harder parts?
Let's maybe just go directly to the second question, and then we can answer them as one. Yeah.
Steve, I heard that lithium-ion batteries are favorable, but the present production of lithium-ion batteries in Europe would take more than 6,000 units to produce enough batteries to grant what they make till next winter.
That's really good stuff. I like that. Yeah. No.
Be clear when we define time frames,
Mm-hmm.
because otherwise we just throw stuff in that doesn't make it.
It's not the battery, the cycle.
I'm going to take my moderator privilege and respond directly. But the core is the models. I mean, it's what question are you asking? And if you're trying to solve for a least cost decarbonized system with an integrated model that looks at generation capacity and storage capacity and multiple weather years, then you can start to solve that problem. But if you think about it in the abstract of like, we have X number of terawatt hours to fill, let's find a technology that chucks into that, I think that's a very challenging road to go down and can miss some big efficiencies. But we'll go maybe to the question on thermal storage. I think it's a really relevant one.
Yes. Yes. don't have ready-made slides about what are the elements to the barriers we need to place. What is important for me is to ensure that the price signals that come from the electricity sector really can arrive also to the heat sector, to the district heating sector in that case. But what varies exactly, I think it changes a lot from one country to another. We're actually currently running a study on this by games, and trying to understand exactly what is the role of heat storage in particular, and how we can promote it. And in that context, we are trying to look at it also for industrial decarbonization that was mentioned before, since most of the industrial processes we need to decarbonize are heat-based processes. To electrify those processes, the storage that we need to buffer as a buffer between the electricity grid and the industrial process, and of course the electricity storage, but it can also be heat storage. Including much cheaper heat storage. So we are also underlining and trying to understand what could be the role of heat storage in that kind of thing. But in terms of interaction between a heat market and electricity market, it's something that is very important. Knowing that there are not so many, the problem we have as European Commission with the heat market is that we don't regulate it at the EU level at all. It's a local market, and actually many member states do not have heat market. So, and very often the prices are fixed or defined by the government in advance. So there's no real markets or price signals moving around as we can see. So it's a difficult area for the European Commission to actually enter the market. But of course, we think it's really good.
Thank you.
Thank you. But it's also the taxation in between, right? It's not about the market. Boundaries for the taxation. It's a video to make.
I think the Commission has done a very good effort on reforming energy taxation. It's not in the Commission that's the challenge.
That energy taxation is part of the European Commission. In fact, we have proposed addition of the energy taxation directive in 2021.
Yeah.
And the fact that it requires unanimity to be approved proves that it's really one of the areas where we don't have much competence. But of course, we can provide guidance to member states. And in terms of taxation, we are insisting that electricity taxation, energy taxation should favor electricity vis-a-vis fossil based. But the heat aspect is also another aspect.
Listen, I'm afraid really, really quick because we were meant to finish 15 minutes ago. So
that it is not only related to the thermal energy storage, the thermal vector, but to the electricity vector. This is due to the fluctuation, the seasonal fluctuation of renewables. It can be assessed that at the European level, the surplus, the capacity to be stored to have a flat PV production will be up to a quarter, so 25% of the annual generation capacity. Okay, so there are very, very big numbers for the electricity. This is the first comment. The second, very quick, regarding the hybrid plants. For example, in my region, they interpret this a PASH to actually hybrid plant, not to force, but to give a premiality in terms of increase of suitable surface, permitted surfaces, okay, in case you install also a storage plant.
okay, I thank you so much. And I think the fact we've gone over so far shows how much interest there is, and there's a lot of topics to discuss. Quick round of applause for our panelists. Thank you so much. Hopefully they'll be able to hang around a few more minutes. And yes, sorry again for running so late. Right, we have some closing remarks now from the conference leader.